Thanks, everybody. So my name is Michael McCune, and I'm joining Rebecca Simmonds today so that we can talk to you about intelligent applications using Apache Spark on Kubernetes. We're both engineers at Red Hat, and we work pretty much on Kubernetes and OpenShift every day, and we use Apache Spark in our daily lives. So we're going to talk a little bit about the process. So what are we talking about here? We're talking about a journey, right? And it's a journey that starts with data, it starts with ideas, it starts with constraints. And the journey is about taking those ideas and turning them into something that you can share with your users, you could create for customers, you can put into the cloud and make something reproducible and accessible. So this is Mount Everest. This is a journey that's quite difficult. It's dangerous, it's expensive. It's not the journey you want to make all the time. And usually I use this slide to illustrate the type of journey that we don't want to talk about. But I'm going to have to change this slide in the future because Becky's actually going to Mount Everest next year. So I'm going to have to put like the moon here or something like that. I don't know where we're going to go from here. What I'd rather talk about is a journey like this. And this is Paddington Station here in London. And under ideal circumstances, the trips here are repeatable. You know how much they cost. You know how long it will take to get where you're going. And these are the type of journeys that we'd like to make as we're transforming our ideas and our data into cloud applications. And so in general, the process that we've been working through and what's been working for us is that we start with our ideas in the notebook. And we kind of do our sketching here. How many people are familiar with notebooks like Jupyter, Apache Zeppelin? Okay, I mean, I kind of figured. So we start with our work there, and our data scientists examine, the data that's coming in. They start to create algorithms that get used. Then we want to take those ideas and bring them into containers. And maybe we start by just having local containers where we're building our applications. And eventually we take those containers into the cloud and we turn them into applications that we can have for our users. Now, what I'm going to do is talk about a little bit of the fundamentals and some of the concepts that we kind of deal with. And then I'm going to hand it over to Becky and she's going to talk about some of the technical implementation details. So let's talk about containers. How many people here are familiar with containers? Okay, I'll go through this pretty quickly then. So what we're looking at here is just, this is kind of traditionally a process on a host operating system, right? This would be like bare metal. We have some sort of process. It's got a, process ID table. It can see other things in that table. It's got a root file system. It's got access to networking. And what we started to do was we started to put things into virtual machines. And virtual machines look very much like bare metal. You still have the same accesses to the same type of resources on the system. And what the container runtimes brought us in many ways was an easy way to access the capabilities inside the Linux kernel and the namespaces and the security constraints that go with them and start to modify what these processes can do. And so as we started to bring these container runtimes together, it became easy to create things like Kubernetes, like Mesos, different types of container orchestration platforms. Because once you can deploy these processes across host nodes, and you can change the way they're networking, and you can build, network overlays and whatnot, this is how we build up these orchestration methodologies. And so the reason I wanted to bring this up is because containers are the main unit that we use when we're kind of trading programs and, even trading notebooks and whatnot. And so if we're talking about containers, oftentimes what goes hand in hand are microservices. And how many folks here are familiar with kind of microservice architectures? Maybe you've heard about it. Okay, so a fair number of people. So imagine what we have here is some sort of monolithic application. And this might have been the way we designed applications, in the past. We put everything together. We've got some sort of code component. We've got maybe some sort of API component. Our data is in there. But we don't want to build our containers that way. We want to start to decompose them and build them into separate pieces. And so what we start to do is we break apart this application into separate microservices that can each address a different concern. And some of the reasons that we do this is that by breaking them apart like this, they become very modular and flexible to play with. We can deploy them in many different places. We can put them under different situations, different testing examples. We can change the resources they have. And as we build them, something that you might hear a lot about is stateless versus stateful services. And so when we're building these microservices, we want to make sure that we try to push towards a stateless way of deploying them. And what I mean by that is we can deploy these containers without having to extend some sort of deep state into them. So we don't have to launch them and then run configuration scripts that can modify the way they're behaving. We want to make sure that they can just keep being deployed and kind of configure themselves on their way up. And then lastly, because we are talking about cloud environments, and oftentimes these things are distributed across multiple machines, multiple zones, multiple regions of the world, we need them to be network resilient. So if one piece drops out, you can't have it destroy your entire application. And these properties give us some kind of interesting things we can do when we get them to the orchestration layer. One of those things we can do is start to play with load balancing our services and horizontal scaling. This is a term I'm sure many of us have heard. There's been some great talks already today about scaling. And what we can do with the microservices, like in this case, let's say this is our API gateway to a big application we have, and we see that traffic is coming in to the extent that it's swamping this API gateway. Well, now we can use some load balancing in our cloud. We can horizontally scale just the API component, and maybe the rest of the application works fine. So we can get very fine granularity on what we're doing with the application. Another possibility that becomes very easy to play with is kind of A/B testing or red-green or blue-green testing, or in this case, green-green testing, right? You can use the same type of load balancing and networking to deploy multiple versions of the microservices that you're creating. And in so doing, you can measure the outputs from them. You can kind of compare them to see which one is creating the best experience for your users or your customers. And then lastly, something that you might have heard about is the term self-healing. This oftentimes goes hand in hand with the container orchestration platforms. And if we think about the ideas of stateless microservices and these modular, flexible, kind of network resilient apps, then we can start to do things. We can have the orchestration layer look at the health of our container. And if it sees that the container is getting into poor health, it can automatically bring that down and launch a new one. So in this case, maybe we have some sort of data component, and if it starts to become unhealthy, Kubernetes could bring it down for us and then relaunch it. So how does this all tie into intelligent applications? And what we're looking at here is kind of a diagram of some sort of printing press, right? It's kind of a complicated machine. It's got all these different gears. But what I like to kind of take away from this, and what I kind of think about when I look at this image, is the way that the microservices fit together. You can kind of add gears in. You can add to it in small pieces. You can build it out. And this is really what I think about when I think about the microservices. And so if we extend that into intelligent applications, and what we like to talk about as intelligent applications are applications that learn or become better from the data that they process. You could think about apps on your phone like Spotify or something, where once you've rated a bunch of songs, it's going to recommend new songs to you. And so this might be an example of an architecture of an intelligent application. So we've got events coming in from the left-hand side of this. There are some transformer services that are maybe doing our ETL type operations. We might have another microservice that's federating all that data. Some of it's going to a training module, which is another separate service that's creating the models that will get used again. Lastly, it might be published out to the far right-hand side, where we have web and mobile, where the data could end up for our users. Or maybe we want to archive it in some sort of data store. But what I want to focus on when we're talking about intelligent applications is really these pieces, right? And these are the pieces that we might build as microservices that fit together to create an application pipeline for us, or a greater intelligent application that can kind of do these things. Now, if you're kind of familiar with the history of using Hadoop and Spark and kind of large processing clusters, what I want to kind of turn to now is how does Spark fit into this microservice model? And the way that I like to kind of characterize it is as democratizing compute. And so historically we might have a large Hadoop cluster, we might have a large Spark cluster, and we say we're going to put Yarn in front of this, or we're going to put Zookeeper in front of it, and we're going to allow that to queue up the jobs that everyone wants to do. And so in this respect, we have our resource manager that's controlling different applications that can talk to the Spark cluster, and then the cluster scheduler is telling us which jobs can run at any one time. And so in this example, app 1 is running, but app 2, 3, and 4 aren't really doing anything. They're waiting for their opportunity to do something. And so one of the things that we've been doing is taking Spark, bringing it into the container namespace so that we can have an interaction that's more like this, where Kubernetes, which is our resource manager, but you could be using Mesos or something along those lines, the orchestration manager can determine which apps should run based on their needs. And the Spark cluster is now a series of containers that live inside the namespace. And so the applications can be much more responsive based on the actual resources that they're using. So this is a little bit of the groundwork, just talking about the concepts that we kind of play with every day when we're building out these applications. And what I'm going to do now is I'm going to hand it over to Becky, and she's going to dive into one of the examples of an application that we've put together that combines, geographic data and user ratings, and she's going to kind of walk through the technical details. So, Becky?
Thanks, Mike. Right, for the second half of this talk, I'm going to demonstrate an application that we've put together. So the aim of this second half of the talk is to empower others with tools and tips to go from prototype to production using Jupyter Notebook and Apache Spark. I want everyone in this room to come away with some tools, some tips and techniques to be able to make their own cloud-native application from prototype to production. So, why prototype? I've got 3 reasons here. I think basically you can get a proof of concept. So there's no point in trying to develop an application that is fundamentally wrong or not going to work. You also get this idea of using agile methodology and the idea that you can have short sprints and a minimal viable product. This way, you're making a small local instance of what you want to put on the cloud, you check that it's correct, and you're reducing the waste of wasted time. If you're like me and you've spent months and months on one project, for me, it's either going to work or and I'm not going to give it up. So it helps to stop that. So, requirements for your prototype. Right, you need a use case. If you're lucky, like me, I've got a use case about something I'm really interested in, but a lot of the time it can be quite business cases that you're going to use. You also need a problem domain. As I said, there's no point in building an application that doesn't actually solve a problem. It's not very useful. You also need to get a data set. This can be hard, even though we're in this age of all this information and like open data sets, it's actually quite hard to find data, and this can even be within your own company. So you need to make sure there's a source for you to use for your application. And you also need some tools and techniques to be able to make the prototype quickly and easily. So my use case is 2 things I'm really fond of. 1, travel, and the next, wine. So what's the problem that we're going to solve? Well, I want to know where to travel and by knowing what the best wine is. So, my data set. I found a CSV file on kaggle.com that had varieties of wine, it had the country they were from, a score, and regions. So for this talk, we're going to focus on country and score. I'm going to take the average score for each country and then display this on a map so that you can tell where to travel. So, as you've all said, you're very familiar with Jupyter Notebook. This is the tool that we're going to use to prototype. Why are we going to use Jupyter Notebook? Well, as I've said, it's quite easy to actually get that CSV data that I said I was using and then experiment around with it and see what we can actually achieve. And because we're using a map, it's really great for incorporating a lot of packages. So I can use a map package and be able to visualize it really quickly in the notebook without having to look at like application servers and checking whether it works. And as well, these notebooks enable cross-team collaboration. So as Mike said before, we have this ability to give the notebook to data scientists to help us with our data analysis, and me as an application developer can then use that analysis and make an application. So, fingers crossed, demo time. So, this is my wine map notebook. So first of all, I'm just going to import these packages that I said I'm going to use to deploy the map. Next, we're going to use Spark. So this just creates a local instance if there isn't one already, and is just used through the notebook. Really easy and quick. 1 line of code. We're then going to need to manipulate the data. So what are we going to use to hold the data? Well, as I'm using a CSV file, it's got a lot of columns and rows. So a data frame is best for column data. So that fits really well. A little tip is if you've got a lot of data, remember this is loading this into memory, so maybe cut little bits and pieces out, as I found out the hard way. Oh, and maybe found out the hard way now. Let's have a look. I think it may need some commas. No, it doesn't need commas. Oh dear. Mike? It was working earlier.
Yeah, I'm not sure.
Well, anyway, just imagine that worked.
And the point here really is that we're developing the technique in the notebook, right? So this is where the experimentation can happen. So sometimes when you're experimenting, you run into these catastrophic failures. And you'd rather fix it here in the notebook than have to deploy it to the cloud and then figure out that you're like, you've just crashed a bunch of containers in your application. So, all right.
It's a lot less costly, but just a bit embarrassing when you're doing a talk. So we've done the prototype, and we've got a proof of concept. And then what we're going to do is now take this into production. So as I said, I have this CSV file. This isn't very robust, and it's not going to give us the sort of querying and processing ability that we would from a database. So it'd be really good to move that data into a database, which can be accessed from anywhere as well. So if you think about this CSV file, I've just got a local version on my computer in a folder, whereas with a database, you can deploy that anywhere on the cloud and then attach to it with different notebooks or different applications. So as I've said, I've mentioned the cloud. So we want this idea of a scalable application. So as Mike mentioned before, we were on about microservice architectures. Now, if we put this application in the cloud, this allows us to combine different services. So the application I'm going to show you today isn't that analytically heavy, but we can then start to add things into this. And then last of all, you need some testing so that when you run things like a notebook at a talk, it doesn't break in front of everyone. So I was talking about storage and this change to a database. So we're going to use Postgres. This is because, as I've said before, the data is relational. And we're going to use a Kubernetes job to load that data. What this will do is it'll execute until completion. This means that we run the data once, then the job will be killed, and then we haven't got this extra application sitting about, and we'll have our data in the Postgres database. Next part was cloud deployment. So we're going to have this YMAP application that the user is going to access through the web browser, and this will talk to a Spark cluster. The Spark cluster will do the analytics and give the data back to this YMAP, and it'll be displayed in the browser. So I think we've skipped a bit, and this seems like a bit of a higher level talk. So we want to talk about Oshinko WebUI. This is how we get our YMAP application. So what we've done is we've taken the code from our Python notebook and we've put it into a Git repository. So this is our user source code. What we're then going to do is use the Oshinko tooling to take that user source code and inject it into a Spark Python image. So this Oshinko Spark Python image is an image that's already ready and will load in everything you need to run Spark and Python. We're then going to use this tooling to deploy our Spark cluster easily. So if you look at the last diagram, we've got this WebUI. Using the WebUI, you can then deploy a Spark cluster. Then when you deploy your application, you just need to set one parameter of the name of the Spark cluster, and it'll connect. So because I'm from Red Hat, and because I also really like OpenShift, we will be deploying this on OpenShift today. So here we have the full picture of the architecture we're going to use. And the third thing I wanted to talk about was testing. So with the code in the GitHub repository, we're using Travis CI to test the code within that. What that'll do is it'll take your code and it'll deploy it on another VM. Once that's deployed, you can set different tests to be ran, such as setting up the application, testing that the data has been put in the database. So it's very end-to-end, and it'll test from web browser to the storage. So the advantage of microservices here as well is it makes it really easy to test each service. So as I said, you can have these tests for the application we've got now, but you can add in other microservices and then just add testing to that as well. Right, demo number 2, let's give it a go. So we are now on the OpenShift web console. So before I start to go through this, I'm going to go to the terminal and enter the command to set off the YMAP application just so it has time to load. Right, no errors, that's always a good start. So let's go back to the OpenShift web console. As you can see, before the demo started, I've already deployed a few things. The first thing I'll go through is the Postgres database. So this uses a template and then deploys the Postgres for you. If we go to the pod, which is running the Postgres, and you go to the terminal, we can log into that Postgres, and I can show you that the data is already loaded from that job I mentioned earlier. Right, so I've just typed in the command to connect, the username, and the name of the database. If we use \d, it shows you that there is some data there. So this is the data we're going to analyse, and that was previously in this CSV file, so it wasn't very robust, wasn't very scalable. So we've met those requirements now. Now, I did mention, briefly, the Oshinko WebUI. So let's go and connect to that. This here is the Oshinko WebUI, and we have a list of Spark clusters. Today we'll be using the Sparky cluster. However, if you use this tooling, you can easily deploy new clusters by going to the deploy button. Here you can give it a name, and you can say the number of workers you would like. Once you click deploy, the Spark cluster will start to be put together. And once it says it is running, that's when it should be in your console. If we go back to the OpenShift console and we go down, we can see Sparky, which will be used for the demo, and then the new cluster that we've set up. It's got a master and one worker, which is what we were expecting. Now, you can also see that from the command I entered into the terminal to use a template for the Y map, this has been launched now as well. So this is just a container with which uses an image to basically deploy the Python code that we want. So if we go back to the overview, then what we can do is we can create a route. At the moment, we can't access this because we don't actually have a URL. But once we expose this URL, we'll then be able to go to the map. So if we click on this, that'll eventually load our map. So as we can see on this Oshinko console, there's this idea of like microservices and different containers and different services and this isolation of concerns. And if you're using the Spark Cluster Manager, you've got this really easy way to start up your Spark clusters, and you can also scale and delete them really easily. And this means that you can focus more on this idea of intelligent apps. And like Michael mentioned, so you can just design what you're going to process, what you actually want to achieve, rather than having to fiddle around with configurations. So if we go back to the URL for the Y map, we can see it's actually working. Yay! So this is what we should have seen in the notebook. You can see there that it's highlighting the average number, the score for each wine. And I think this is showing me I should go to Switzerland, I think. Or am I just being silly? But anyway, there. So to go back to the slides. Conclusions from that demo. I've shown an easy-to-use tooling. This Oshinko WebUI and S2I tools, which you can also use, are really great for deploying cloud-native applications quickly. It can mean that developers can focus on this intelligence and adding to applications. And using this microservices architecture, you can add in different bits across teams from data scientists and developers. And it just makes it more robust and scalable deploying it on the cloud. So as you've seen, we've got this database that we can now connect to from anywhere. We could have more than one. We can have multiple data sets. And it's more portable, so it's not just stuck in the notebook. We can deploy it anywhere and once again sort of send it across the teams. So what would be next? Next, as I've said, we'd like to add more microservices. So maybe a better recommendation system. Although a score is great, I'm sure there's different data sets and different things we could add in. And we're hoping to do this dynamically. I'd also love to be able to enter in your views so that it's not just this CSV file I've got, is that we're creating a map based on what real users think. So thanks for listening, and thanks for laughing along when my demo didn't work. If you go to the URL there, there's lots of tutorials about making your own cloud-native applications and a lot more explanation about the Oshinko tooling that I've briefly mentioned. My name is Rebecca Simmonds. You can get in contact with the details below, and this is Mike. And you can get in contact with him with that information.
We have a couple minutes for questions. If you have a question, raise your hand and I'll run the mic over to you.
Okay. So basically, when I was seeing the cluster creation, is it working or the mic is working? Hello? Okay. So when I saw the cluster creation, let's say Spark cluster, I just saw like, you can add the workers. But is it something like we can also scale it in a way like, selecting the size of the machines and stuff like that?
Yeah, you want to? Okay. Yeah, actually.
I didn't see it, so.
Yeah, there's a lot you can do with it. What I'll do is I'll go into the tool real quickly here and just show you. So controlling things like the size of the cluster and whatnot, and the size of the actual containers, like how many cores they might have or how much memory they might have, that happens more at like the Kubernetes level, because OpenShift is basically an enterprise distribution of Kubernetes. So some of those things would happen more at the policy layer, but from the tool, what you can actually do, and I'm probably going to get lost here. Look at this. Okay, so let's see if I can. How do I make this bigger, Becky? There we go. Okay. All right. So if I wanted to, when I was deploying a cluster here, I could go into this advanced cluster configuration. And what this gives me access to do is that from here, I can start to do things like set up the configurations that would go into the master and the workers and the drivers. So if you're familiar with configuring Spark, you can kind of give it some configuration files that have various values for how much memory it should use or what packages it might have in it. This would give you access to those type of options. And then, like scaling wise, like Becky was saying, if we wanted to, we could just we could scale this up and say, give us 5 workers, scale it and go back to here and see if I can get this thing done. All right, there we go. And if I go down to the bottom, you can see that it's already scaled up to 5 containers here basically, and those containers are distributed throughout the cluster. Additionally though, because of the way that the Oshinko tooling works, and we're using Kubernetes as the source of truth here, I could actually scale these inside of the OpenShift console or from the command line, and you can see it's already scaled up to 3 pods. This you can do while you're running an application. So while your driver's running, you could update it like that. And then if I go back to the cluster manager, you can see that it's figured out here that I've upgraded it to 3. So, yeah, that's kind of how it would work.
Did you have a question?
Thank you for the talk and for the demo, for the live demo. That's quite, not many people do a live demo in a conference.
It's a little nerve-wracking.
My question is related, it's a bit off topic, but it's when you want to make a prototype, you use notebooks for making prototypes, and it's good, but you want to validate your prototype against real data. What happened with this data? It's or in a database or in a data storage that is shared between different people with different permissions. How you can make sure that your prototype, that you don't give access to certain people, to certain data in your prototype.
Right. You want to? Well, okay. So a lot of it depends on your infrastructure and how you're setting things up. Like if you were using, let's say Kafka, right? Then what I would do is I would probably use Spark's Kafka connector. And if I had to have like credentials going through that, then I would manage the credentials through that. And the way that you could do that inside of Kubernetes is that Kubernetes has an object that it calls a secret, right? So there's a way for you to store credentials in a secure way inside of Kubernetes. You could plumb these things through so that your application pods would have access to those credentials. And then when my application runs, it would log in, to Kafka or to Postgres. And one of the things, it went by kind of quick, but the command line that Becky was putting in there, she was passing some of the parameters to log in. And that's maybe how you would do it in prototype. But once you get to production, you would start to do things like isolate your data sources and use, what I would do is use Kubernetes to isolate these things. And this is one of the things that OpenShift adds, is OpenShift adds an RBAC mechanism, role-based authentication. So I might separate my data sources into different projects inside of OpenShift, and then I could rely on kind of the underlying network layers to isolate those resources. So there's a couple different ways you could do it. It would really depend a lot on where your data is at rest. What we're looking at here is like kind of more on the prototype side of things. So we started with a CSV file because that's just kind of easy. But then if I wanted to share it, and maybe you and I were working on a project together, I might take that CSV file, put it into a Postgres database inside of OpenShift, and then we could share that database, and then we'd make sure we have the same data. Thanks.
All right. Thank you, everyone, for joining us. Let's give our speakers another round of applause.